Hey guys, Vance here. So previously, we explored aircraft engines, machines that fight gravity, chasing lightness and speed. We compared them to car engines, those compact bursts of efficiency that move us every day. We learned that both share the same heartbeat, control through combustion. But this time, we are dropping back to sea level, to a world where weight doesn't matter. Only endurance does. Where engines don't sprint, they endure. Welcome to the realm of ship engines, the machines that move nations. Long before the roar of exhaust or the scream of jet turbines, humanity learned to move by wind and muscle. But the moment we trapped steam in iron, motion gained independence. The first practical steam engines, 18th century. Newcomen and Watt were meant for mines, not movement. Yet by the early 1800s, steamships changed everything. Robert Fulton's Clermont became the first to prove that power could defy the wind. Trade routes stabilized, timetables were born, and oceans stopped being unpredictable. That rhythm, piston push, repeat, became the pulse of the modern world. Steam was humanity's first taste of mechanical freedom. Every engine since then, car, aircraft, or ship, is part of one family. The heat engine, different descendants, same ancestor. The creed is simple: turn heat into motion, turn motion into control. Cars chase responsiveness, aircraft chase lightness, ships chase torque. A typical car engine spins at 6,000 rpm. A ship's main engine, barely 100, but that 100 rpm can hold 200,000 tons of steel through water for weeks on end. That's not horsepower, that's patience made mechanical. Let's rewind to the golden age of steam, the 19th century. Steamships were the marvels of their time, iron giants crossing oceans with rhythmic precision. But early steam engines were crude, single expansion machines wasting much of their heat with every puff. Then came refinement. Before diesel conquered the seas, engineered perfected one last masterpiece: the triple expansion steam engine. Instead of using steam once and releasing it, it expanded it three times, first in a high pressure cylinder, then in the intermediate, then low pressure. Each stage squeezed more work from the same steam, like reusing strength three times before letting go. It was elegant, efficient, almost musical. Pistons breathing in sequence, three notes repeating endlessly. For half a century, these engines powered merchant fleets and warships alike. They were the bridge between raw steam and refined combustion, the final symphony before diesel took the baton. By the early 20th century, the world had a new addiction: efficiency. Internal combustion was leaner, lighter, and faster to start. Cars were the first to adopt it, chasing independence on land. Aircrafts followed, chasing the sky. Ships hesitated. Why rush when endurance already worked? But eventually, diesel proved irresistible. Slower revolutions, denser fuel, and much reliability. Where cars revved high, ships slowed down. Where cars used gasoline, ships preferred thick black bunker fuel, closer to asphalt than petrol. The result? Engines that don't roar, they thud, each stroke deliberate, each revolution meaningful. A heartbeat designed to last decades. Imagine standing inside an engine cylinder and still having headroom. That's what happens aboard the world's largest ships. Take the Wärtsilä-Sulzer RTA96-C. a legend in marine engineering. 14 cylinders, over 100,000 horsepower. Each piston heavier than an entire compact car. At idle, it turns at 60 rpm, slow enough to count each thumb, yet strong enough to move a city of cargo across an ocean. It burns 200 tons of fuel a day and somehow remains efficient for its size. Strip away the scale, though, and you will find the same logic as your car's diesel. Intake, compression, ignition, exhaust. The same rhythm, just magnified to titanic proportions. A car engine is a sprinter. A ship engine is a power lifter. One lives by acceleration, the other lives by endurance. Cars rely on lightweight alloys, precision timing, and clean emissions. Ships rely on steel, redundancy, and torque so constant it could pull continents closer. But they are still family, obeying the same physics, the same hunger for controlled explosions. Even horsepower, the unit we still use, is a relic from the steamships that started it all. Different arenas, same bloodline. Innovation has never been one way. At first, ships led the way, bringing diesel to the world. Then cars caught up, chasing refinement. When fuel injection, turbocharging, and computer controls matured in the automotive world, ships borrowed them back. Now marine engines use electronic governors, variable injection timing, even hybrid assistance, all born on land. And with global emission laws tightening, the world's biggest engines are learning humility from the smallest ones. Who'd have thought? Cargo ships taking cues from hatchbacks. In the last episode, aircraft engines taught us that lightness can be power. Here, ship engines teach us the opposite, that weight can be wisdom. A jet burns fuel to escape gravity. A ship burns fuel to embrace it, to dig into water's resistance and use it as leverage. Both conquer their environments, not by defying physics, but by mastering it in opposite direction. Air conquers space, water conquers distance. Car bridges the two, balancing agility and endurance. 3 domains, 1 philosophy. Transform energy into purpose. The ocean is changing, and so are its engines. Modern cargo ships now test LNG, hydrogen, and hybrid electric assist. Battery packs support slow-speed maneuvering. Energy recovery systems reclaim heat from exhaust, a trick borrowed straight from hybrid cars. We've come full circle. The largest engines on Earth are learning sustainability from the smallest ones on land. That's evolution. Mechanical humility meeting modern necessity. Machines have always mirrored us. Cars represent freedom, aircraft represent ambition, ships represent endurance. A car engine lives fast, burns bright, and rests often. A ship engine keeps going, same rhythm, day and night, through calm and storm. Maybe that's why its sound feels reassuring. A slow, steady pulse reminding us that progress doesn't always mean speed. Sometimes it just means not stopping. From the deck of a freighter to the highway of a city, every engine speaks the same language. Motion. Different volumes, same melody. The car's engine hums of freedom. The ship engine rumbles of endurance. The aircraft engine roars of ambition. All of them descendants of that first spark. The human need to move. From the open road to the open sea, every engine has a story, and together they tell ours. Hit like if you enjoyed the video.